and other sorts of puzzle solving. Prepare yourself for a weekend filled of problems, making new friends, and having a great time. So without further ado, we'll turn it over to our FNE chairs, Julia and Shiki, to describe the events that we prepared today.
Thank you for that lovely welcome. Hi, I'm Shiki.
Hi everyone, I'm Julia.
And we're at a Friday night.
We kind of our Dane Street spin on a kind of trivia contest. It's a lot of fun. We haven't done one before. It is team-based, so if you bring a team of like 6 to 10 people, that's pretty much a good size. Room for 270 at 7 o'clock. I hope we'll see you. This will be our 23rd time running one here at HMMT, so some of you may have done one before. But yeah, I hope to see some of you there.
He's been really helpful in making this process smooth. So even though he's not here today, we can bring him along as well.
To do it, but it turns out that this is actually quite difficult to prove, and this was only proved almost 400 years later by a math professor by the name of Thomas Hales, who I think is now at Pittsburgh. So he proved this in the year 2000. Yes. Right, it's a very good question. So the reason is these objects that I put up here are very, very special. They show one of a kind. And so their analogs don't exist unless in dimensions less than 8. So they're very symmetric, and the amount of symmetry sort of forces them. First of all, these kinds of objects only exist in dimensions or multiples of these. And this is the smallest one. And yeah, roughly that's these. Not a complete thing. Well, in 3 dimensions, unit sphere means all those points which are dimension 1 from the origin. This red ribbon I've got here. But algebraically, it's given by this equation, say like x squared plus y squared equals b squared equals 1. And we can make this very similar.
Try and square the relative angle between them. And in the last case, I win if I disagree rather than if I agree. So I have to put the 1 minus in here to get the disagreement calculated. Okay, so now it's just a matter of, so if you do know calculus, like this is now the time to, or if you don't know calculus, either way, you can either like take derivatives of this thing or just like plot some cosine functions and like figure out what's going on. But it turns out that the correct answer has a very nice sort of symmetry to it. So I think it's going to be theta d0 is pi over 8. Theta d1 is minus pi over 8. And theta a1 is pi over 4. Just in degrees, like this is like 45 degrees. This is minus 22.5 degrees. 22.5 degrees. And if you plug into the probability of winning, plus, I think, root 2 of 4, which comes out to about 0.85. So this is like of the 5 or 4, and it's still close to being consistent with the data this year. So, yeah, I guess I'm basically out of time, so I'll just conclude by, you can plug in these numbers, we've got this, I have made a sign error. Then people went and did this in the lab. So they first did it, I guess, like Alain Aspect, who's like a French physicist, did this in like the 80s. Oh, this is so cool, you can do it, but, you didn't do the experiment quickly enough to rule out that, like, there might be signals propagating from Alice's bottom. Like, your experiment was actually super slow. And like, you didn't choose the angles randomly. Like, there are a bunch of like loopholes in what you did. But like more and more people have like closed more and more loopholes. And now there's like experiments that do things like they pick the values of the challenges X and Y based on like the radiation from two galaxies, like two opposite sides of the universe. It's like kind of certify that they're uncorrelated with each other. So now we're really confident that either there's some insane cosmic conspiracy or local variables are false. This tool, this like little game that CHS Nation just developed, surviving authors on this thing won the Nobel Prize in Physics in 2022. And this tool has also been super useful in quantum computing research to understand how to test quantum computers. Because this is kind of an experiment that can convince someone who has like really no need to assume anything about the inner workings of Alice and Bob if they're doing something quantum and not classical. So that's what my research is about, and yeah, thanks for listening.
A lot more than you expected. Like, do you have an estimate of a percent? If you were just to like make a random estimate, what percent of the students are still here? Congratulations, more than 50%. That's amazing. That means that you have successfully turned HMMT into something more than just a tournament. Yeah, congratulations. I try to avoid too many heavily political comments, but I will say I am actually trying to get to a situation where we can have lots of kind and clever people in leadership. This is in fact one of the things I'm trying to do, okay? Well, because I run this program, we have like 100 high school students in this. 30 of them graduated last year, and well, we do know about colleges, because 6 of them got into Harvard. 13 got into MIT. Don't clap, don't worry, because that's overrated anyway. All these colleges things, oh sorry, I didn't mean to say that. Obsession with colleges is overrated anyway, alright? So don't worry too much about that.
On there,